Hello, my dear students. Now let us discuss your test number 6. So let's see the very first question, guys. The very first question is very important and very fundamental, I will say, because it's based on the Gibbs free energy delta G, and I'm sure आप सबको पता है अगर रिएक्शन को spontaneous होना है तो delta G should be negative, right? And for a non-spontaneous reaction, delta G, the change in Gibbs free energy, is positive for the reaction, right, guys? So let's check out the question. Suppose that a reaction has delta H minus 40 kilojoule and delta S at what temperature range will it from spontaneous to non-spontaneous? So कहाँ हमें दिया है डेल्टा H, हमें दिया है डेल्टा S और हमसे पूछा वो रेंज जब ये spontaneous से non spontaneous हो जाएगा, right? So I hope you all know delta G is equal to delta H minus T delta S, and for reaction to be spontaneous delta G की जो वैल्यू है वो क्या आनी चाहिए, नेगेटिव आनी चाहिए, right? And for non spontaneous process delta G is positive. So let me put the values here, guys. 40,000 joule, right? Because 40 kilojoule it is, minus T minus 50 joule per Kelvin. So basically it is minus 40,000 plus 50 T, right, guys? Now if I want my delta G to be negative, so how it can be negative? If this 50 T, yes, this value T, this term should be less than the minus 40,000 value, then the overall answer will be negative. ये बड़ी होगी वैल्यू, ये छोटी होगी पॉजिटिव वाली, तभी ओवरऑल आंसर नेगेटिव आएगा. So let me check, guys. So delta G is equal to this. So let me rearrange. Temperature is equal to temperature. Yes. So for spontaneity, the boundary condition, I'll put delta G is equal to 0, right? The boundary condition is delta G is equal to 0. If delta G is negative, spontaneous, positive, it will be non-spontaneous. So let me put delta G 0 here, and I will have T is equal to 40,000 divided by 50. Got it, guys? Yes. So this comes out to be 800 Kelvin. So 800 Kelvin is that temperature, that boundary temperature above which or below which the change will happen. Right, guys? So you are supposed to see the range. You are supposed to check the range. Yes? Yes, everyone? So if the temperature is 800, that is the boundary condition. That is the boundary condition, guys. Yes, that is the boundary condition. So below 800, the reaction will be spontaneous. Above 800, it will be non-spontaneous. So I will choose my answer as D, right? Because they are asking about the range. की range क्या रहेगी? So to calculate that boundary value above and below which you are supposed to put कि delta G की value हमारी 0 है. So you can see, guys, right? Now the next question is, at constant volume and at 27 degrees Celsius, the heat of combustion of 7.8 grams of benzene is 327 kilojoule. What will be the heat of combustion of benzene at constant pressure? So heat at constant volume and heat at constant pressure. So heat at constant volume is delta U, and heat at constant pressure is delta H of the reaction. Internal energy change and enthalpy change. And I hope you all know delta H is equal to delta U plus delta NGRT for the reaction, where delta Ng is the change in the gaseous mode. So at constant volume, the heat of combustion of 7.8 grams of benzene is given to you. What will be the heat of combustion of benzene at constant pressure? So this you are supposed to calculate. This is given to you. Just make sure you are supposed to calculate for 1 mole, right? So first you will write the reaction. Benzene C6H6, when undergoes combustion, it will form CO2 and H2O. Right, guys? This is how it is. The combustion reaction, any hydrocarbon undergoes combustion will form this. Got it? Yes. So let me balance this. So it will be 6 CO2, 3 H2O, and now your oxygen 12, 15 by 2 here. Right? this is the delta H of this reaction, the enthalpy change of this reaction, that is the enthalpy of combustion of benzene, that 1 mole of benzene. Yes, that is 1 mole of benzene, because it is mentioned at constant volume, so we'll take it as delta U. Got it? So for 1 mole, the value is, for 1 mole, we define the enthalpies per mole. So for 7.8, it is 327 kilojoule. 7.8 grams of benzene के लिए जो value है, that is 327 kilojoule. तो एक मोल मतलब 78 grams के लिए जो value होगी, that will be per mole. So we'll calculate the value of delta U per mole. We'll put it here, and delta G is the change in the gaseous moles, right? So gaseous moles on reactant side and product side. So you can see in this reaction, this is a gas, this is a gas. So change in gaseous moles. What will be the change in the gaseous moles, guys? This is liquid. So delta Ng here is gaseous moles on product side minus reactant side. 6 minus 15 by 2, that is minus 3 by 2 is the delta Ng. So you put minus 3 by 2 here. Right, guys? Yes. Delta H is delta U plus delta NGRT. चेंज इन गैसेस मोल्स आ गए हमारे -3/2. आर पता है, टेम्परेचर हमें दिया है 27 डिग्री सेल्सियस, जिसे हम केल्विन में कन्वर्ट कर लेंगे. एंड मेक श्योर जस्ट ये आपको पर मोल के लिए वैल्यू पुट करनी है. 7.8 ग्राम्स के लिए दी है. पर मोल ऑफ बेंजीन मींस 78 ग्राम, द मोलर मास ऑफ बेंजीन. पुट हियर, यू विल गेट योर आंसर, राइट? सो द आंसर विल कम आउट टू बी A. You can check here, delta U for 1 mole is -2370 kilojoules. And of course, putting the values in the equation, you'll get your answer. Just be careful with the units. That's it. Right? So the answer you'll mark here. That is A part. Got it? Okay, guys, let's move on to the next question. Considering the entropy as the thermodynamic parameter, the criteria for the spontaneity of a reaction. Okay, guys, this is about the second law of thermodynamics. For a spontaneous reaction, and entropy of the universe should increase. Yes, this is what your second law of thermodynamics is. Entropy of universe matlab entropy of change of surrounding plus entropy of system. System plus surrounding, that should be increasing in the process, then only it will be spontaneous. So कौन सा आंसर आप मार्क करोगे? For a spontaneous process, there should be overall increase in the entropy of the universe. That means delta S of system plus delta S of surrounding. The change of entropy should be positive. It should increase. The entropy should increase, right? So the change in system plus surrounding should be greater than or equal to 0. This is the definition as per the definition, second law of thermodynamics. Now the next question is, the standard enthalpy of formation of ammonia is -46 kilojoule per mole. Ammonia N2 plus H2 gives NH3. So for 1 mole, we are supposed to write, this is 1/2 here, this is 3/2, right? So when 1 mole of ammonia is formed, the enthalpy change is -46 kilojoule per mole. Now, if the enthalpy of formation of H2 from atoms is -436 and that of N2, the formation, so the formation is opposite of dissociation. So if I write H2 gives 2H, the dissociation, right? Yes, H2 gives 2H. The answer is delta H for this reaction is minus, instead of minus I'll put plus, because I just reverse the reaction. फॉरवर्ड रिएक्शन इज डिसोसिएशन, बैकवर्ड रिएक्शन इज फॉर्मेशन ऑफ H2. हमें फॉर्मेशन की वैल्यूज दी हुई है. सेम विद नाइट्रोजन. नाइट्रोजन की फॉर्मेशन की वैल्यू अगर -712 है, तो डिसोसिएशन की वैल्यू क्या हो जाएगी? प्लस. अगर फॉरवर्ड रिएक्शन एंडोथर्मिक, तो बैकवर्ड एक्सोथर्मिक, राइट? नाउ यू नो द डेल्टा H ऑफ दिस रिएक्शन, एंड आई होप यू ऑल नो कि अगर बॉन्ड एनर्जीज दी होती हैं, सो डेल्टा H ऑफ अ रिएक्शन इज bond energy of reactants minus bond energy of products, right? So this formula we are supposed to calculate. Delta H of this reaction is given to us, that is equal to bond energies of reactant. So I have nitrogen here, I have hydrogen here, their bond energies are given to me. Ammonia, in ammonia I have 3 nitrogen-hydrogen bonds, right? So bond energy of product means 3 into the bond energy of nitrogen-hydrogen bond. Putting the values of bond energy, you will get your answer, right? In reactant, put the bond energies of nitrogen and hydrogen given here. Ammonia have 3 nitrogen-hydrogen bonds and you are supposed to calculate the value of nitrogen-hydrogen bond. Yes, so you can see here, bond energy of reactant minus bond energy of product, half into bond energy of N2, that is 712. 3 by 2 the bond energies of H2, that is 436, minus 3 times the bond energy of nitrogen-hydrogen bond. Very simple. Just put the values and you'll get your answer. Just make sure no calculation mistake. Now the next question. A process will be non-spontaneous at all the temperature. कब प्रोसेस नॉन स्पॉन्टेनियस होगा? अगर किसी प्रोसेस में एनर्जी बढ़ रही है और एंट्रोपी कम हो रही है तो इट विल बी नॉन स्पॉन्टेनियस एट ऑल टेम्परेचर. So if your enthalpy of the reaction is increasing, that means delta H is positive, and entropy is decreasing, that means delta S जो है वो नेगेटिव है, तो आपका जो रिएक्शन है वो स्पॉन्टेनियस नहीं हो सकता, इट विल बी नॉन स्पॉन्टेनियस, राइट? सो इंडीड द आंसर we'll mark is A. The process with negative entropy change. Negative entropy change means कि entropy decrease कर गई in the process. Yes. So first is dissociation of calcium sulfate to this. Solid से gas अगर बन रहा है तो of course entropy बढ़ रही है. Sublimation of course randomness बढ़ रही है, entropy बढ़ रही है. Dissolution of iodine in water, that is also iodine is solid, उसको dissolve करोगे, molecules की जो randomness entropy है बढ़ेगी. Synthesis of ammonia from nitrogen and hydrogen. So let me write the reaction. N2 plus 3H2 gives 2NH3, right? So we have 4 gas moles on reactant side and 2 gas moles on product side. That means the number of gas moles decreases in the reaction. That means there is decrease in the entropy. So this process will have a negative entropy. So we'll mark our answer as D donkey. Now let's check the next question. In an reversible process taking place at constant temperature and pressure in which only pressure volume work is being done, the change in Gibbs free energy and the change in entropy satisfy the criteria. So of course, delta S should be positive for the reaction. Entropy should increase and Gibbs free energy should decrease, right? So delta G should be negative, whereas delta S should be positive. What is guys? Spontaneity. Okay, let's have another question. For 1 mole of a non-ideal gas, please take care. Undergoing the following change, pressure is given, temperature is given, volume is given. With the change in internal energy, delta E is given. The change in enthalpy of the process. Change in enthalpy of the process. Delta H is equal to delta U, or you can also write it as delta E plus delta NGRT. This you know, but because we write delta NGRT just because the gas is ideal, we replace PV by nRT, but it is mentioned कि जो gas है वो non ideal है, तो हम यहाँ पर delta PV ही लेंगे instead of NGRT. We cannot write it replace PV by nRT, right? So delta E plus P2V2 minus P1V, right? So guys, delta E is given to you. P1, this is V1, this is P2, this is V2, right guys? You can put the values and you can see your answer. Got it? So what should be the answer? Simply putting the value, guys. So delta, let me put here 30 plus P2 into V2, that is 20 minus 2 into 3, that is 6. So it is 30 plus 14, that is 44. Yes, 44 liter atmosphere should be your answer. Got it, guys? The unit is liter atmosphere. We are just solving the question in liter atmosphere. So the answer indeed is C. Now let's have the next question, guys. The enthalpy of neutralization of acetic acid by sodium hydroxide is minus 55.3 kilojoule. So basically, you know, acetic acid is a weak acid, right? So we need to dissociate this weak acid by applying energy. And if instead of acetic acid, neutralization of the base is done by a strong acid, the overall release energy, that is enthalpy of neutralization, is this, right? तो जब एक स्ट्रॉन्ग एसिड एक स्ट्रॉन्ग बेस को न्यूट्रलाइज करता है तो इतनी एनर्जी रिलीज होती है. वहीं अगर मैं स्ट्रॉन्ग एसिड की जगह एक वीक एसिड ले लूं तो जो एनर्जी रिलीज हो रही है वो इतनी हो रही है, कम हो रही है. क्यों कम हो रही है? बिकॉज सम पार्ट ऑफ एनर्जी इज बीइंग यूज्ड इन द डिसोसिएशन ऑफ वीक इलेक्ट्रोलाइट. वीक इलेक्ट्रोलाइट खुद से तो 100% डिसोसिएट नहीं होता है, तो अगर हमें उसे डिसोसिएट करना है फॉर न्यूट्रलाइजेशन, तोड़ने हैं आयंस, तो उसके लिए एनर्जी लगती है, बॉन्ड तोड़ने के लिए एनर्जी लगती है. तो अगर वो खुद से डिसोसिएट हो रहा था, अगर वो स्ट्रांग होता तो ओवरऑल इतना एनर्जी रिलीज होता. अब क्योंकि सम पार्ट ऑफ एनर्जी इज बीइंग यूज्ड इन डिसोसिएटिंग एसिटिक एसिड, तो कम एनर्जी रिलीज हो रही है. तो इन दोनों वैल्यूज का जो डिफरेंस है माय डियर स्टूडेंट, दैट इज द एनर्जी जो कि आयोनाइजेशन डिसोसिएशन ऑफ एसिटिक एसिड के लिए यूज हो रही है. वेरी सिंपल, ओरली यू कैन से द आंसर इज 2 जूल. जो 2 जूल्स का डिफरेंस आ रहा है वो 2 जूल कहां लग रही है? एसिटिक एसिड को ब्रेक करने में, आयंस में, राइट? Okay, now the next question. A process will be spontaneous at all temperature. Process कब रहेगा spontaneous हर temperature पे? अगर process के होने से entropy change जो है positive रहेगा, enthalpy change negative रहेगा. मतलब if in a process entropy is increasing and enthalpy is decreasing, the process will be spontaneous. Energetically favorable, energy कम हो रही है, stability बढ़ रही है, entropy बढ़ रही है. So the answer indeed is C. Okay. Now the next question is, in which of the following reaction is delta S positive? इनमें से किस रिएक्शन में जो डेल्टा S है, एंट्रोपी है, वो चेंज जो आ रहा है पॉजिटिव आ रहा है, मींस एंट्रोपी बढ़ रही है. सो लिक्विड से सॉलिड, ऑफ कोर्स एंट्रोपी कम हो रही है, रेंडमनेस कम हो रही है. 3 मोल्स ऑफ गैस टू 2 मोल्स ऑफ गैस, राइट? अगेन मोल्स ऑफ गैस कम हो रहे हैं तो एंट्रोपी में भी कमी आ रही है. सी ऑप्शन, लिक्विड टू गैस, लिक्विड से गैस में कन्वर्ट हो रहे हो. गैस में मॉलिक्यूल्स आर मोर रैंडम, दे हैव मोर एंट्रोपी, सो ऑफ कोर्स डिसऑर्डर ज्यादा है. द आंसर विल बी सी. Now the next question. For the reaction CH4 plus 2O2 gives CO2 plus 2H2, delta H is given to us. The absolute value of delta U. So we are going to use the important formula. Delta H is equal to delta U plus the delta NGRT. Right? R is given to U. Temperature is also given to you. 300 Kelvin. The temperature is 300 Kelvin. Right? And delta H is given to you. That is minus 212.7. R should be used in calorie. Temperature is given. Delta Ng, change in gaseous moles. So you can have a look at the reaction. So on reactant side, product side, I have 1 gas mole. And on reactant side, I have 3 gas moles, 2 plus 1. So change, delta Ng is 1 minus 3, that is minus 2. The change in number of gaseous moles is minus 2 in this reaction, guys. You can have a look. Right? Yes, just put the value in this equation. So you have delta H, you have delta Ng, that is minus 2. R is 2 calorie per mole. Temperature is given. Calculate delta U. Very important equation, one of the most important equation that you use in thermochemistry, guys. So be careful. You get so many questions on this equation, the relation between enthalpy change and internal energy change. So enthalpy change can also be given as the heat at constant pressure. Internal energy change can also be given as the heat at constant volume in many cases. So just putting the values, you will get your answer as minus 211.5 kilocalorie per mole. The entire question we solve in kilocalorie unit, right? Calories. We solve this question in calories only. Got it, guys? Yes or no? So just be careful about the units. Here the R unit is calorie. So if you are taking kilocalorie here, just make sure you make the required conversion here. Right? So that's all for this test, and wish you all the best for the upcoming test, guys.